So this is a video tutorial to help you write formulas of simple ionic compounds. The first thing you need to recognize is you need to recognize the charges that ions make. The noble gases, of course, do not make charges because they have a full valence shell. The halogens, group 17, make a -1 charge when they make a charge because they gain 1 electron to look noble. Oxygen, sulfur, selenium make -2. Nitrogen, phosphorus make -3. Going to the other side of the periodic table, group 1 elements, including hydrogen, make a +1 charge. Hydrogen can sometimes also make a -1 charge, but for the purposes of this, we're going to say it makes a +1 charge. Beryllium, magnesium, calcium, strontium, group 2, make a +2 charge. And then often and easily forgotten are the metals in group 13 are going to make a +3 charge. But notice it's the metals that make those charges, not the nonmetals. Okay? Then two others that you're going to want to know that come up fairly often. Zinc always makes a +2 charge. Silver always makes a +1 charge. Every other metal can make more than 1 charge when it forms an ion. And we'll deal with those in a later video or at a later time. Okay? So, use a periodic table. You should be able to recognize the charges that are made by any monatomic ion, any ion that is by itself, that is one element. Okay. At least for the main group elements. So let's look at writing formulas. The main idea for writing a compound is that compounds are neutral. Compounds are always neutral. So when you write a compound, the overall charge needs to be 0. All right? So compounds are by definition neutral. Ionic compounds are always a metal and a nonmetal. So let's just take, for example, magnesium, combine that with bromine. When I write a formula for magnesium bromine, what I'm going to do is I'm going to write out the element with the charge that it makes when it makes an ion for each the metal and the nonmetal. Bromine makes a -1. Okay? And then I want to look at the charges and make the charges cancel. I can add as many of these as I need to make the charges cancel. If I look right now, the charge of magnesium is +2. The charge of bromine is -1. +2 - 1 does not give me 0. So I need to add more bromines to cancel out the 1 magnesium. So if I have 2 bromines, or 2 bromides, with a -1 charge, then +2 - 1 - 1 gives me 0. That makes a neutral compound. So I'm going to write this by putting magnesium and bromine together. We always write our metal first. I have 1 magnesium ion, and I have 2 bromide ions. Again, 1 magnesium and 2 bromides. And that makes it neutral. That gives me a compound which is neutral. A couple things about this before we move on to the next example. First, when we have a 1, we generally do not write the 1. We just leave it as blank. Oops, I didn't mean to erase that. We generally just leave it as 1. So this would be the normal way that we'd write magnesium bromide. The second thing is I want to point out the name. We call this magnesium bromide. For anions, for negative ions, we change the ending to IDE because this is actually called a bromide ion. And we call this a magnesium ion. We don't, for metals, we don't change the name. We literally just add the word ion to the end of the ion. Okay? All right. So that's why sometimes you'll hear me say magnesium bromide instead of bromine, because I'm trying to point out that it's an ion. Okay, let's try another example. Let's go ahead and keep magnesium, but instead of bromine, let's go ahead and move over. Let's go to oxygen. So oxygen has a 2- charge, and again, the charges sometimes you'll see them as written as +2 or 2+, or -2 or 2-. It doesn't really matter too much. So when I look at this, I see that one magnesium has a charge of -2. I see that one oxygen has a charge of -2. I think magnesium's +2, oxygen's -2. So notice that the charges are going to automatically cancel out with just one of each. So I could write Mg1O1, but again, we don't write the ones. So the formula for this is literally just one magnesium with one oxide, and that gives me magnesium oxide. So don't add numbers if you don't need to add numbers. Let's try another one. That one's almost too simple. So let's go ahead and change our metal this time. Let's go ahead and change it to sodium. Sodium is a popular one. Let's put sodium together with phosphorus. I think this is an example we did in class, but I'm going to go ahead and do this one again anyway. So again, sodium has a +1 charge. Phosphorus has a -3 charge. So when I look at it as written with just one of each, I see that this is not neutral. The -3 needs more positives to cancel it out. So all I'm going to do is I'm going to add more positives. I'm going to go ahead and make another one. And I'm going to look and say, okay, so now I have +2 and -3. Still not canceling out. I need more positives, so I'm going to keep adding positives. So I'm just going to do that another sodium. Notice the sodium doesn't just come with sodium. I can't change the charge of sodium. Sodium is always +1. But now I have +1, 2, 3. So I have 3 sodiums that cancel out the one phosphorus with a -3 charge. So the way I write this is I'm going to write 3 sodium, Na3, and 1 phosphorus. Remember, I don't write the 1, but writing a P tells me that. So this is the formula for sodium phosphide. Again, it's neutral because I'm adding up the charges. But this is the number, probably should make that orange so you guys can match it up. So this is the number of sodiums that I have, not the charge. The charge tells me how many. The formula, what I write, is actually how many. Okay? So the charge needs to be neutral, but the number at the bottom is how many, not the charge. So Na3P is my final answer for sodium phosphide. Let's do another. Okay. Let's make this one a little bit more difficult. Let's go ahead and do strontium with phosphide. Okay, so strontium, Sr, has a +2 charge. Phosphide has a 3- charge. Again, don't worry about which comes first, the number or the charge. It's the same either way. So when I look at this, I see that +2 does not cancel out -3. I need more positives. All right, so it's tempting to just add an Sr +1, but I can't do that because when I make a copy of this, the +2 comes along with it. And so I go, I don't know what to do. I have +4 and -3. Well, I need more negatives, so I'm going to add another negative. I'm just going to duplicate another phosphorus, another phosphide ion, and I'm going to go, that made it even worse. It didn't actually make it worse. It made it better. And here's why. I have -3, that gives me a -6, and +4, so I need more positives. And why it made it better is because look what happens when I add another positive. I'm just going to add another one. I can add as many as I want. I can just keep going. So as I add another one, I can see that I get +2, 4, 6. That gives me a +6 overall charge and a -6 overall charge. So now this thing that I have written is neutral. I have 3 strontiums. So I'm going to write that as SR3. If I can have my iPad cooperate with my writing. And I have 2 phosphoruses. 1, 2. So notice the 2 is because I have 1, 2 phosphoruses. The 3 is because I have 1, 2, 3 strontiums. So mathematically, when I add all the charges on this, all of the charges together give me a 0 charge. And so my final formula for that is just Sr3P2, and that gives me strontium phosphide. That's how you write these. That's about as hard as these get. We will deal with other ones a little bit later, but there you have it. Good luck in solving these.